Okay, hi everyone, and welcome to this talk. My name is Roman. I'm part of the Nokia's product management team, and today I will be your guide for the next 30-ish minutes to talk to you about streaming telemetry and gNMI, and the open source project gNMI-C in particular, that is an intuitive to use gNMI CLI and a feature-rich telemetry collector. But before we dive into the meat of this presentation, I would like to take a measurement of this room. Who heard of gNMI as a protocol? That's quite a lot. And who still uses SNMP mainly for monitoring? Yeah, that's what I thought. Okay, so I will ask you to lower your voices a bit because we're going to a sensitive topic. We are entering a cemetery. And we are looking for a particular grave, right? So here's the gravestone. It says, here lies SNMP. You are not simple, not dealt with management. And the dates of life is May 1990 all the way back to June 2018. So if you know what happened in May 1990, that was the date when SNMP v1 RFC was minted. But what drastic series of events happened in June 2018? Who killed SNMP? We know this for a fact. This is actually two stellar gentlemen from Google. They went on stage at Nanox 73 back in June 2018, and they said, SNMP is dead, guys. And you can go to YouTube and type in SNMP is dead, and you will find the talk. That's the actual title of the talk. And I will not repeat what they said. They had a lot of data points and nice graphs, and they plotted a lot of information why they thought that SNMP is going to be irrelevant for the next years. But now you're probably thinking, okay, get off the stage. We are not Google. Not everyone is Google. We are not hyperscalers. Whatever the issues they had might be related to the massive scale that Google operates on. And while this is valid, I should say that we are across the board, across the networking board, we see switch or shift from monitoring to telemetry. And why do we see that? Well, there are many reasons. Technical ones I explained by the Google folks back at the Nanox 73. I would explain more like from the common sense of what's happening right now. Even if you are not a hyperscaler, you know one fact about your network. The network is growing, right? We are not shrinking our networks. We have more and more network elements to manage. And that pushes some pressure on the monitoring stacks that we operate. We also have streaming telemetry collectors or applications that work on the data that demand more high definition data to work on. And the reason for that is that applications are now smart enough to provide some really useful insights based on the data that we collect with high definition, high granularity. But you also know that if you ask your SNMP collector to go and poll the data with sub-minute intervals, your CPU will sweat. Because what happens is that SNMP kind of wakes up your router and shouts at it, give me the counter 1.715, whatever, and router goes full sweat and tries to extract the data from the databases, from TCAMs, and provide a data frame to your collector. And that is CPU heavy, right? You see that CPU spinning quite fast when you want to lower the collection interval. And also, one interesting fact about SNMP is that by default it uses UDP, everybody knows that. And it's okay to miss a frame for your interface counter. You don't really care. You will get another data frame and you will approximate, and your graph would look exactly as you expect it to be. But now we have systems that are more like operating the network based on the streaming telemetry that you collect. What happens if you miss a data frame that says my BGP peer went down? You don't want to do that. And for that reason, you have to have a reliable transport delivery, which is HTTP or TCP-based protocols that would enable that certainty or guaranteed delivery of the data. So back to Google. They said, okay, there are a lot of inefficiencies of SNMP. It's time to move on. There are better alternatives to that. And they came up with a protocol that's called gNMI. So gNMI stands for those who doesn't know what it is, it's gRPC-based network management interface, and hence the acronym. It uses gRPC framework to create the protocol, and gRPC framework enables you to write client-server applications that allow you to build remote procedure calls as if the calls were local to your application. There are a lot of information on the internet around gRPC. We will not focus on it here. We'll focus on the gNMI. So what gNMI does for you as a network operator, it kind of tries to solve two things. It is a network management interface. So you can configure your network elements with gNMI as you do with netconf, JSON RPC, REST API, RESTconf, with a few key differentiators. And also, it makes it easy and performant to stream data out of the boxes. So a key point here is that gNMI kind of solves two problems, streaming telemetry and network management, all in a single package. So it is quite interesting to see that when there is a void left by SNMP, there's usually not one protocol or not one solution that tries to fill it, right? And gNMI-C was created by Openconfig consortium or led by Google, but there were others. And we all know the other standards body that is quite vocal. IETF came up with a protocol that's called YankPush. That was the draft name, but the official name is subscription to Yank data store, to Yank notifications for data store updates. Quite a mouthful, right? And this RFC is really great. If you go and read it, it has a lot of things. It's pluggable. It has different transports. It can do this, and that. It has it all, but lacked adoption. There are very few network operating systems that implement YankPush, not even to say the RFC version of it. So it kind of comes to a bronze winner. It has it all, but nobody cares about it because adoption is not there. There's no interest in that one. Maybe things will change, but this is the current state of affairs. All right, so what is gNMI-C to gNMI? gNMI-C is an open source project that we created at Nokia back in 2019 when we started to see that there's a ramping interest in gNMI, and we wanted to fulfill the void of lacking of tools to work with gNMI. So gNMI-C is an open source project that does three things. So first, it is a command line interface for gNMI targets. Now, what is a CLI for gNMI targets? Imagine you want to learn what gNMI is and you have a gNMI-enabled router or switch. How do you learn that? You typically go and take some CLI tool and play with it, be it for netconf console, or maybe it's a Postman for REST-based devices. So we wanted to create the same for gNMI. And I personally went to the internet looking for an already existing CLI because why wouldn't it be already created if the protocol is there? But all we found was tools written by developers to developers. And you know how it looks. No documentation. If you wanted to download the binary, it's not there. You need to build it, or you need to have a dev environment. So it was not user-friendly at all. So we decided to build a CLI that would be joyful to work with and would kind of be a de facto CLI for gNMI targets. So that we did in 2019. And the next step was to create a collector out of it. So now if we know how to interact with the gNMI device, it makes sense to create a daemon that would run as a streaming telemetry collector, which you can scale, you can deploy in production, you can ingest data from your network nodes and push it to the outputs. So that's the highly available and flexible telemetry collector as well. And lastly, we also provide the Go API for gNMI so that you can write your own automation scripts or programs, configuring the nodes from the Go programs, or creating streaming telemetry collectors yourself using the API that we provide. And this API is more human-friendly than the auto-generated gNMI API. All right, so the base is set. Now, starting with the CLI portion, what gNMI-C CLI is, it's a bunch of commands, right? So you use CLI as a command line interface. So which commands do we expose? We have RPC-based commands. gNMI has 4 main RPCs: capabilities, get, set, and subscribe. They are self-explanatory, and gNMI-C exposes them as subcommands. So you can type gNMI-C get, and you will get information from the device. And we kind of design those commands after the gNMI specification. So by saying gNMI-C CLI is intuitive, is that you read the CLI you read the gNMI specification, and you recognize which commands you need to use to perform a certain action. Besides that, we have utility commands, and utility commands are auxiliary commands that help you work with any gNMI-enabled target. So you can generate diffs between the intended configuration and running configuration, or you can generate compressed paths to work with your streaming telemetry collector. some things that make your life easier as an operator. And then when we designed the CLI, we also wanted it to be really flexible in configuration. It's really painful when the CLI doesn't have a flag to configure anything and you need to ask a developer to add it. So we decided we will add everything that gNMI specification has to offer as flags. So of course you can use flags as you would typically use with the CLI tool by providing it on the terminal, and that makes it very easy to configure CLI tool of gNMI-C. But not only flags are useful. If you want to run your gNMI-C CLI in a CI/CD setting, environment variables are your friends. You may be having them as a secrets in your CI. So we have environment variables provided to you for every configuration aspect of gNMI-C CLI. So you can use either flags or envars, or you can use a file configuration. You can use a file, put all the options there, and all the options are one-to-one mapped between each other. So all three configuration options, flags, envars, and file configuration options, they have the same names for each and every parameter. Okay, sweet. Now let's see.
Sorry, Roman, are you taking questions in the middle, or?
I think it's better to wait till the end. Sorry, just to keep the flow going. So now we have gNMI-C and a few examples for typical commands, right? So you have get RPC. Get is basically your equivalent of polling. You say, dear router, I want to get information from this particular path. In this case, this is a host name. And with this command, you will immediately get all the data for this particular path in your terminal. So that's a quick way to see which data the router will return to you should you have asked for it in a once fashion. The fun happens when you use gNMI-C set. That is what enables you to configure the box from the comfort of your terminal. So you can say, I want to change the path, and in this case, this is the admin state of the interface, and you want to enable it. So you provide it with update value. But gNMI-C has a lot of options to provide setting of configuration. It's not really convenient to use CLI style setting for large configurations. Like if you want to have a full BGP configured in one go, you wouldn't want to type it in the CLI. For that reason, we have set files, so you can compress all your configuration in a file and ask gNMI-C to use this file as a set source, and it will configure it out of the file, out of the content that you pasted in a file. So there are many options to use set with gNMI-C in a CLI mode. I encourage you to read the docs. We have a lot of examples there. And lastly, I would like to talk about gNMI-C subscribe command. So with subscribe command, you might wondering, why do you need a subscribe on the CLI? It's not feasible. This is purely for testing. You want to see what kind of data you will get from the network node should you subscribe to a particular path. Will you get the right timestamps? Will it send it with the right encoding, or will it have proper intervals set? So that is what gNMI-C subscribe command doing. Now, CLI is cool. It gets you going. You can learn what gNMI is, how to use it, why is it better than SNMP. But then eventually you have to step into the land of deploying this streaming telemetry collector in your network. And the way you do it is that you deploy a specific telemetry collector in your network in a daemon mode so that it runs indefinitely until you stop it. And a typical telemetry collection stack looks something like this. You have your gNMI-based devices, you have your collector, and then you have a certain output that stores your data, or where your data is going to. In this case, this is Prometheus, and some visualization layer, typically Grafana, is used. So let's dive into the streaming telemetry collection portion of gNMI-C. The way it works is that you create a configuration file. In this configuration file, you define your targets. And targets are basically your routers or switches that you want to subscribe to. You specify the addresses, the authentication data, and after that, you define the subscriptions. So subscriptions are basically a collection of paths that you would like to subscribe to, and some subscription-based configuration, like the intervals that you're interested in, and maybe some subscription options that you would like to pass on. And lastly, you define the outputs. This is where your data will end up being pushed to, right, from after it is ingested by gNMI-C. What you do next is that you bind subscriptions and outputs to targets. why we do that? We want to give you flexibility. What kind of routers should be associated with which subscriptions and where to put the data from. So you can mix and match and create really flexible data pipelines with that particular binding. So speaking of outputs, outputs are really important when you're speaking when you're talking about streaming telemetry. This is where your data will be ended up being. And in gNMIc, we have three major output categories. So one is databases. Databases will store your telemetry data, and most of the times it is time series databases such as Prometheus or Influx or some commercial systems like Victoria Metrics and the likes. And we do have plugins for most of them, right? For the most common ones, at least. We also have a chance to pass your telemetry collected metrics to message queues. Why do you want to have a message queue? Well, some people want to have some complex data pipelines. They want to pass the data to other systems that are consumers from the message bus, or maybe you want to fan out your telemetry data to different outputs for multiple databases, Influx, Prometheus, something else. Again, message queue can be a mediator or a buffer before you do that. And lastly, there is a very simple output, which is a file or standard out for debugging purposes or for demos when you want to show how it works. You can use those kind of outputs as well. And we have way more than just that. We have UDP and TCP raw sockets that you can push to. So again, it's all listed in the docs. One thing that people don't really realize that often is that when you subscribe to a data, you don't immediately store it. Most of the times you need to message it a bit. You need to change something. You need to unify the data that you receive from multi-vendor network, and that's where processors come into play. A data manipulation is very important when you ingest the raw data, especially in the multi-vendor networks, and you want to have a commonality between the data that you collect. For example, you want to convert the types that you receive. You receive a string, but you need a number, so you can do a conversion. Or maybe you want to group different events that you receive from the network as a single metric before you store it in the TSDB. This is, again, a task for a processor. And recently, Karim, the lead developer of gNMIc, added a few interesting processors, namely JQ and Starlark. These kind of processors enable you to write mini programs that would consist your logic, and you can program how you want to change the metric that you ingested in a raw format from the network devices, and then you can augment, enrich it, and pass it over to the output. And then when you define the processors, you again have a flexible option to bind it to a specific output so that different outputs can have different processors, and you can chain the processors to make sure that you have a flexible pipeline. All right, now the interesting part about gNMIc is that it offers clustering out of the box. Maybe you're wondering, why do we do gNMIc as a streaming telemetry collector if, for example, Telegraph was already there? CLI was not there. It made sense to create a CLI, but Telegraph was already part of the game. Why bother and creating a streaming telemetry collector? There are many answers to that, but the main reason is that Telegraph doesn't offer you clustering. You can't have a cluster of Telegraph collectors in a free version. And with gNMI cluster, with gNMI, we offer you clustering out of the box. So you can have multiple collectors forming a cluster, and your targets, your gNMI enabled routers or switches, will be distributed between your cluster members. So you will have a leader elected, you will have followers, and your targets will be really evenly distributed between the members of the cluster. If a member dies or something happens, it can happen that you lose a region and one of the members was there. The targets that it owned will be redistributed automatically. So you will have a highly available cluster with target redistribution enabled out of the box. Now, we understand that gNMIc and streaming telemetry is kind of new. There is a lot of things that are quite new to network engineers, all these protobuf specifications and complexities when you need to have a TSDB and some telemetry application stacks next to them. For that reason, we created deployment examples. We wanted our users to be really not feeling lost when they see a lot of new terminology and a lot of new tools, which they typically don't have in the networks. So we created deployment examples, and our deployment examples use Container Lab as a network underlay so that you can deploy everything in one go both the network underlay, the gNMI collector, the TSDB as a container, Grafana as a container, everything comes up when you deploy the lab, and we explain the use cases, how gNMIC can be used there. So for you, you can start easily by selecting, do you want a single node collector cluster? Do you want a clustered deployment? Do you want to use TSDB or you want to use a message bus? And then a relevant deployment example will be shown and you can follow and see how it works. So as the slide shows, there are many ways you can use gNMIC as a streaming telemetry collector. There's plugins to console, to service registration, a lot of stuff that you can dive into. So last year, we had a chat with Openconfig team, and they said, you know, gNMIC is cool. We kind of see that it's relevant to the users and it does its job well. So why don't you donate gNMIC to Openconfig? And that's what we did. And now gNMIC is part of the Openconfig, and the project is still open source. Nothing's changed. The lead developer is still there. It's just we have a bigger name, a bigger consortium that backs the project up. So that sounds interesting. I think yes. If you want to explore the gNMIC, this is the main documentation portal for it, gNMIC.openconfig.net. And this documentation portal has all the information that you might need around installation, deployment examples, how to configure it using CLI or streaming telemetry collector or Go API. Everything is there. We encourage you to try the deployment examples, pick and choose whatever TSDB you are most comfortable with, get your routers connected to the gNMIC cluster and see how it all works. If you want to get in touch with gNMIC community, and there are a number of customers here already who are using gNMIC as a telemetry collector, you can find us at GitHub issues or GitHub discussions. And lastly, we encourage you to support open source projects. It's not easy to create a very good open source project, and I think gNMIC is one of them. So give it a star. And I have a lot of stickers with gNMIC with me, so if you want to pimp your laptop, I have a bunch, so check out. With that, thank you very much, and we're open for questions.
Thank you very much, Roman. I see Alex did run away, but it's running back.
Yeah, there was a gentleman with a t-shirt, SNMP is not bad. I hope he's not here.
Yeah, so I had just a small question about the settings for the CLI command. So you had slides about how you can set the environment and command line, and that you can also stick the settings into a file.
Correct.
Is there an environment variable for the file name of the file?
That's a good question. I think we don't have it.
I have a suggestion.
Yeah. Yeah, you can definitely just use the shell, and if you have an environment variable that points to a path, then you can use these as export it as an envar and use it as a CLI argument. So should be possible, but yeah.
Yeah, Henrik from Intempus, I just have a small question, like what takes precedence when you show all the 3 different configuration options?
Yeah, great question. So CLI flags or arguments take precedence over envars, and these take precedence over the file. So you can have a file and then override with envars and then override with CLI arguments.
Yes, Wilhelm from Europa. I was wondering, we use SNMP exporter today with Prometheus, and I'm wondering how does gNMIC compare performance-wise and so on?
So what SNMP exporter does is that it takes the SNMP messages and pushes it to, or Prometheus scrapes them, right? With gNMIC, it is a bit different. You get your data out of your network elements with gNMI protocol. So your network elements should support gNMI in the first place. But then you can get a lot more granularity and a lot more high definition data. So you can select which paths you want to subscribe to. So you can get FIB or RIB data even, or you can subscribe to things that are not available in your SNMP MIPS, for example. But it can be vice versa. For example, you have SNMP MIPS for everything, but gNMI is not there on your device. And then you have no choice, right? But performance-wise, gNMI is way more performant than SNMP, even if you use SNMP exporter on the nodes. So you will be able to get more data with less CPU pressure.
And another question at the back.
Hi, Rene from Nordic. You say SNMP is dead, that's fine. And then you mentioned another protocol, YankPush, which was not push, which was dying because of no adoption. So what is the adoption of gNMI?
Well, it's a good question. Thank you for that. So the adoption for gNMI is quite growing. So now with major vendors out there, like the big four, every router that is not lower grade has a gNMI support. And when we say gNMI support, that's protocol-wise. So gNMI is supported as a protocol. The other question is your network element has the Yang model that covers all the state and configuration of the box? That's a separate question, which is not really relevant to gNMI, but in general, how good your vendor is with augmenting their configuration and state with Yang models. Because gNMI by default uses Yang modeling to get access to the data, and the less data covered by Yang is, of course, making this data unavailable to any protocol, gNMI or netconf or any other model-driven interface. So the adoption rate is growing. It is already quite good. So you can have Cisco, Juniper, Arista, Nokia already supporting it. And yeah, it's getting better and better over time.
Any more questions? Oh.
Jan Perry from Forskningsnettet. Just continuing this, now you said the top models would have support for this. Do we expect it to grow downwards so that in the end I'll have the Office switch being enabled for gNMI-IC?
Yeah, I would say that probably not. So the old gear will likely not get gNMI support. The new one will, but it's always a matter of pressure from the customers asking for a new interface to be implemented. So it's not a rosy current state of affairs. There are network elements that only has SNMP currently. So
a quick question, because we're kind of running late into lunch, and they take the food off early here.
Yeah, I was just follow up on legacy devices. Is there like some kind of translator from SNMP to gNMI, or is that possible?
Not that I know of. Not that I know of. So if you have a very old switch which only has SNMP, then you have to stick to SNMP, right? Or wait until you will swap this to a newer switch.
Okay. Thank you very much again, Roman.
Thank you.
Great talk.